Okay. So let's go ahead and start our conversation here today with the mean value theorem. You'll hear me refer to it almost exclusively as MVT, the mean value theorem. I'm not going to write all the basic requirements of the mean value theorem. We'll talk about that in just a second. But here's what you absolutely positively need to know about it. F prime of C equals F of B minus F of A over B minus A. Right? It doesn't look complicated, but it's actually, some mathematicians actually refer, this is actually the fundamental theorem of calculus in some ways. And if we got time, maybe towards the end of the period, I'll talk about why that is. Or maybe I'll just kind of give you a hint on why that is. But what this is saying is the following, and then we'll come back to the details. What's this saying? What is that? What is F prime of C? What does that mean? No pun intended.
At a point on the derivative,
Yeah.
It will equal right.
Yeah, we'll just let's start there. So he's saying on a certain point of the derivative, okay? And so what is that giving us? The slope of the tangent line, right? So this is telling us, and I'm going to use his words here. I'm going to say this is the derivative value at a point. I'm just going to write like that. Keep it real short. It's the derivative value at a point. The point happens to have the x-coordinate c. Agreed? We could also say that that is the slope of the tangent line at c. I guess maybe I should just change that one to c as well, right? Same thing. Okay, good. Let me add one more thing here. Let me erase that because that just looks so bad. Let's make that just c. At c. We could say it's the instantaneous rate of change at c. So what I'm trying to do is try to kind of like hit all of the things that a derivative is. Like this, it is the derivative of this function at c. We could also, an application of that is talking about the slope of this curve at c. Or we could talk about the instantaneous rate of change at c. So now let's say we're talking about some particle that's moving through space or whatever. Okay? All right, now let's look at the right-hand side. So if this is the derivative at c, so that's like literally abstractly what this is, what would be equivalent to this on this side? What is that? This is the value of the derivative of c. What's that? Yeah, that's the, if you want, we could just say it's the slope. Oops. I'll say it's the slope of, I'll just call it a line. How about that? The slope of the line. Or actually, that might actually pair it better with this one, huh? This would be the slope of the line. I mean, slope of the, oh, actually, let me put it this way. What word goes over there? Here we had tangent. What word goes over there? Secant. Good. Yeah, let's do that. Let's do secant. Let's change that to slope of secant. Secant line. That's good. What about this one? The average rate of change. This is the average rate of change, right? So here's what this, actually we need to probably talk a little bit about the requirements. What are the requirements? That's probably actually really important. What are the requirements for the mean value theorem? Yes, ma'am. Okay, so F has to be continuous. Yes.
It has to be differentiable.
And it has to be differentiable. Good. Now here's the thing. I'm teaching Calc AB, as you guys probably already know. in addition to this class. And I'm teaching limits right now. And we're talking about continuity. And the kids are like, and I call them kids, they're young adults. They're always asking, why do we need to know about continuity? Why do we need to know about continuity? You guys are all through calculus. Why do we need to know about continuity? Can you tell me? Yeah?
Because a lot of the time, if the function isn't continuous, it isn't always differentiable.
Right. Okay. What is the main thing? Like every section we do, what's there usually in almost every section? There's some sort of theorem or something, right? Guess what almost every theorem says in it?
Yes.
Has to be continuous. The reason we study continuity is we can't do most of the calculus stuff if it's not continuous. Furthermore, we can't do a lot of stuff if it's not differentiable. So if the function's continuous and differentiable, then we can do all the fun stuff that we learned how to do. Like the mean, if it's not continuous and it's not differentiable, I can't do the mean value theorem on it. It's required. And so this is something to think about when you actually take the AP exam. If they don't really tell you, if they just give you a function, you technically have to say, well, the function is continuous and differentiable, therefore I can apply the mean value theorem. Okay? Okay. So the only other thing I think I want to mention about this, unless you guys want me to do an example, which I'll be glad to do, we can make one up, is this. What is, oh, yeah, I remember what it is. Sorry. This is an existence theorem. What that means is this. This theorem tells us that this value exists. That's all it tells you. It doesn't tell you where it's at, and it doesn't tell you how many there are. So that's the bad news. The good news is it guarantees that there is some C value where it exists on the interval A to B, on the open interval A to B. So if A is at 0 and B is at 2, it guarantees that there's some C between 0 and 2 where this is all true. It doesn't tell you where, and it doesn't tell you how many. And it could be 1, it could be 50. Now, obviously, I'm not going to give you one that has 50, but I might give you one that has 2 or something like that. Does that make sense? Does anyone have any questions? Do we need to see an example of the mean value theorem?
Yes.
Yes. Okay. So can we, so we're going to do an example here real quick. Let's not make it too difficult. Let's pick a fairly easy but not linear example. So can we do a parabola of some sort? Can someone think of a fairly easy parabola that we might want to use?
7 minus x squared.
Okay, fine. So f of x is 7 minus x squared. Okay, and then we also need to talk about the interval. So let's go from, let's go from 0 to, let's just say 2. Is that okay? You want to work this one out? Or do you want me to work it out? Actually, let me work this one out because I'm going to have you guys play here in just a second. So let's say I'm now asking you, so the question is find C, blah, 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 such that the mean value theorem, blah, 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 right? Something like that. Find the value C on the interval 0 to 2 where the mean value theorem is satisfied. Agreed? Okay. So what I'm going to do here now is I'm going to come back to this, and I'm going to, I wish I could get rid of that little blue thing I just drew there. It was maybe not the smartest thing I've done, but we'll see if I can grab that. Cool. I want to cheat a little bit. Edit, copy. I'm going to come over to this slide, and I'm going to go to edit, paste. Maybe. Yeah, there we go. And I'm going to see if this will let me move that. I want to move it down. Yes. Oh, that's not what I wanted to do. There we go. We'll move. Oh.
Go to the circle.
Okay. Doom, doom, doom. Let's get rid of all that. So this is how you actually waste time. Paste. I want to grab that. There we go. That's what I wanted to do. Okay. Good?
Yes.
Let's start with, do you mind if I start with this right side? Okay. So the interval is clearly labeled. Let's do red. Right here, here's our interval. So now I'm going to work with this side of the equation. So I'm going to say, I'll just write actually, let's do it on the right side. Oh no. What did I just do? There we go. I want to undo that last part that I wrote. Ah. Boy, I'm so glad I'm recording this. Okay, anyways, I want to get the right side over here, and I was going to do it over on the right side, but I guess I'm going to do it on the left. So we're going to do the right side. So we know that B is what? 2. A is a 0. So we've got to do f of 2 minus f of 0 over 2 minus 0. So f of 2, what the heck did I do? I've got that all screwed up now, don't I? It was 7 minus x squared, right?
Yeah.
Okay, let me get rid of this if I can. Cut. All right, there we go. So let's go ahead and say that'd be, was it 3?
Yeah.
Okay, thanks. 3 minus 7 over 2. So I think that's negative 2. Oh, wow, this is going to work out nicely. Thank you, Jack. You made this work out. Isn't that nice? We didn't even get a fraction. We got a nice, lovely answer, a slope of negative 2. And that's the slope of the secant line, right? That's the slope of the secant line. Okay, so now we've got the right side. So can you guess what I'm going to do next?
The left side.
Now we're going to worry about the left side. Oh, I skipped something very important. What should I have said at the very beginning?
It's continuous.
Yeah, so since this is a polynomial function with there's no denominator or square roots or anything weird like that, this function is continuous and differentiable, okay? And since that's all apparent, we can do NBT. Okay, so we're doing NBT. All right, so now let's do the left-hand side. So the left side, I think is, it's f prime of c, right? So c is, I don't know what that is, right? So that's what we're trying to figure out. But f prime of x, I think isn't it negative 2x? Is that right, negative 2x? Okay, great. And we want that to be equal to what? We want that to be equal to negative 2. So this guy has to be equal to, man, this is going to work out fantastic. You've made this is, like, I'm so happy right now because I could not have picked a better example. This just works out lovely, right? Because I'm not using a calculator and it's going to work out well. So it looks like x is going to be what here? Looks like x is going to be 1, right? Just divide both sides by negative 2 and you get 1. So, and by the way, that's what c is. So what I'm telling you is the following. What the mean value theorem is telling me is that the slope of the secant line on the interval 0 to 2 is equal to the slope of the tangent line at c equals 1. That's what it's telling me. And we can verify that. Yes?
What's C?
C is the x value. So now let's draw a picture. Let's finish this off. Does Desmos do derivatives? Let's finish this off with a picture. So let's go to Desmos. Oh, and I'll talk about Rolle's theorem in just a second too. So I'm going to go to Desmos and I'm going to start graphing. And I'm going to change my Desmos from, let's go from -1 to 3. And then the y-axis, we're going to go from, let's say, -1 to 8. Right? Hide that now. And our function was y equals 7 minus x squared. Thank you, Jack. All right. And I don't know that it's going to do the derivative. I don't know if it'll do y prime. Yeah, it doesn't know what that is. so I'm just gonna write y equals, you guys would agree that that's the slope, right?
Yeah.
So that, and now let me just go ahead and plug this in here. -1, let's see, get rid of that x. No, that's not gonna do what I wanted to do. All right, I'm just gonna draw on this, okay? So let's draw the secant line, and we were going from 0 to 2, right? Okay, so I think I can draw right on this. I don't know if it does lines. Okay, so I'm just gonna have to eyeball this. We're going from 0 to 2. So 2 would be right there. 0 is right there. So that's horrible. Let's pretend that that's a decent line, but it's not the greatest, okay? So there's your secant line. And what was the slope of that secant line? -2, right? I claim, I don't know if I can change this color here. Oh, there we go. I claim that right here, again, not a very good picture. This is the tangent line, and its slope right there is going to be equal to -2. Now, Alex said, Mr. Allen, what is C? Well, C here is 1. So I'm telling you, let's go back to red, or better yet, let's do black. This is x equals 1, which is the same thing as saying C. So we're talking only about the interval from 0 to 2, right? How many points are on the x-axis between 0 and 2? Infinitely many of them. When I refer to C, I'm picking one of those particular x values. In this case, the C value is 1. And it is the only one that will provide a slope of a tangent line that's equal to the slope of the secant line in this example. Now, if we wanted to, we could talk about what's the equation of the tangent line, which, by the way, that'd actually be not too difficult, right? That would be, let me go to blue again. So what's that point there? Is it 1, 6? 1, 6. So it'd be y minus 6 equals -2 x minus 1. Agreed? That's the slope of the tangent line. And then let's do the slope of the secant line, or the equation of the secant line. Well, what's its y-intercept? 7, right? And what's its slope? -2. So the red thing is the secant line. The blue thing is the tangent line. And the mean value theorem tells us that in this particular example, this is the only tangent line between 0 and 2 that has the exact same slope as that secant line. I'm going to use that tomorrow. That was beautiful. Everything came out whole numbers pretty much, right? Slopes came out whole numbers. The point of intercept, he could have picked probably anything else and it wouldn't have worked out so well. That was awesome. Okay, so I'm going to stop. Oh, actually, let me do one more thing. Are we okay? Yes.
Where would we apply the mean value theorem if we weren't like doing a mean value theorem?
Hold on for 1 second and I'll get to that in a sec. I want to talk about Rolle's theorem because a bunch of you asked about Rolle's theorem. Now, guys, I'm just going to warn you, as soon as I switch over, all of this stuff is going to erase. Is that okay? All that writing, as soon as I switch over, because I have to do this, and that disappears. And now I'm going to go back to the work that we did. And now I'm going to make that example's now over. But I just want to mention Rolle's theorem. Okay. In the example that we did, the slope was -2, correct? Rolle's theorem, the only difference between Rolle's theorem and the mean value theorem is this. Rolle's theorem, the slope is always 0. Rolle's theorem actually was known before the mean value theorem, and then it turned out, because guess what mathematicians do? They like to generalize their results. So this Rolle guy, and I'll be honest, I'm not quite sure if he is the person that discovered Rolle's theorem. Like, for example, the Pythagorean theorem, you realize that Pythagoras didn't come up with the Pythagorean theorem, right? You knew that? Did you know that? There's a guy by the name of Pythagoras, and he is known for the Pythagorean theorem. It was already known for, I think, 1,000 years or so before he knew it. But he's the one that first wrote it in a book, and it became the Pythagorean theorem. I'm not sure that Rolle actually is the guy that came up with this, but hopefully he did. So Rolle came up with this theorem, which is exactly the same thing as the mean value theorem, but it is only in the case when the slope is 0. So guess what I tell my students? Who cares about Rolle's theorem? What's the only thing you really need to know? The mean value theorem. Because the mean value theorem it doesn't have to be zero. It literally could be any slope. It could even be an undefined slope. Okay? All right, now I'm going to stop this because I'm going to answer a question. And the question is as follows.